Annyeonghaseyo and greetings, ninth graders. Welcome to Weather and Climate 9. So today we're going to be talking about fossil fuels. Uh, and before we get into that, I just wanted to do a quick review of our lesson yesterday, which was all about climate. So we learned about what climate is, and I want to talk about the difference between climate and weather. Right? So we focused on what weather was for a while, and now we're talking about climate. So weather. Weather's day-to-day sunshine, rain, precipitation, and temperature, right? And then climate is whether something is tropical, temperate, or arctic. So, for example, let's just pretend it snowed here tomorrow. Maybe I would, I'm talking to Salar-Muku, and I'd be like, "Oh, Salar-Muku, it's like the North Pole here," and it's just a figure of speech, right? It's snowing, sure, but it doesn't mean that like Minnesota has actually become an Arctic climate, right? It snowed for one day. However, if there was always ice on the ground in Minnesota and it never left all year long, then we could say, oh, the climate of Minnesota has changed. Now it is an Arctic climate, right? Trees can't survive throughout the year, only grasses grow. Then we could say that some kind of climate change has happened. So it's really important to distinguish between weather, which is basically short term, day to day. This is what's happening. Even if we talk about a season, right? So if it's a really hot summer, that's weather, right? Uh, because we still have summer, right? We still have winter, we've got summer. If you have seasons, that's weather. But if we're talking about, oh, you know what? We don't have winter anymore because it's so warm, then we're talking about climate. Okay, so climate is kind of these long-term changes that happen very slowly. They take a long time, and another example of that would be in Alaska. There used to be palm trees. Like I want to say, what was it, 55 million years ago? There used to be palm trees in Alaska. It was really hot, right? It was subtropical. It was like probably like Florida is now. And so, anyways, it was a real hot area. It began to cool down gradually, and the palm trees went away first, and later on the deciduous trees, like the trees with leaves that we have here, those went away, and then there were pine trees, and then some areas of Alaska got so cold that even pine trees couldn't survive, and all that was left was just these sort of grasses that would grow during the summer when the snow would melt off the top of the ground. Anyways, climate change. Climate is something that changes very slowly. It takes years and years for climate to change. When we talk about climate, we're talking about weather patterns over the course of a year. When we're talking about weather, that's just the day-to-day stuff. Okay, so hopefully you have a clear understanding of what climate is and what weather is. We'll talk more about this during our review session, so don't worry if you're still a little bit hazy on what it is. Nonetheless, we are talking about climate because we're experiencing climate change right now. Climate change is hands down the biggest sort of crisis that your generation is going to face. I know that like you're struggling with coronavirus right now, so there's a lot on your plate. However, climate change is likely going to outlast coronavirus as the number one danger to not only human beings, but also just life on Earth. And so climate change is caused primarily by the burning of fossil fuels. So today we're going to focus on fossil fuels for our lesson. And so our entrance task is just a real simple question. What are fossil fuels? So what are fossil fuels? Just go ahead and take a minute, maybe hit pause, and then you can pop on the Schoology and just answer the question in the discussion boxes. What are fossil fuels? You don't have to like write a separate document and submit it. So go ahead and hit pause, do that, and when you're ready to continue on with the lesson, hit play again. Okay, so our objectives for today are pretty simple. I want you to understand how fossil fuels are formed. We're also going to talk a little bit about the carbon cycle, but that's going to be kind of like, I don't know, bonus material. Like if you get the stuff about the carbon cycle, great. If you don't worry about it too much. And then for your language objective, I want you to be able to explain what you learned today. Keywords, we've got a few of them. Carboniferous is our first word, and that's the name of a historical period, the Carboniferous period. Organic, which means related to life. Limestone, which is a type of stone that's created from coral. And decompose, which means to rot or to break down into soil. And finally, we have this word non-renewable, which is something that we use to talk about resources. We've got renewable resources like wind, sun, water. Those are things that are not going away. And we have non-renewable resources like fossil fuels. And once you use them, they're gone. You can't make them again because it takes millions of years. And, oh, I'm sorry, our last term is the carbon cycle. Like I said, this is bonus material, but basically carbon on the Earth gets cycled from the atmosphere to the Earth into living things, to deep inside of the Earth. Sometimes it gets pushed down into the mantle, and then it comes back out again and into the air and continues the cycle on and on. Okay, let's go ahead and jump into our lesson. So when we're talking about fossil fuels, most of them were formed during a time period called the Carboniferous period or the Carboniferous era. And this was a time when life began to crawl out of seas, out of the oceans, and began to populate the land. This is also a time when one of the supercontinents called Pangaea was forming, and at this time, Earth was covered with these gigantic forests, and actually it was a very interesting time because there was this explosion of plant life, and plant life had created so much oxygen on Earth. The amount of oxygen went up from 21% of the air was oxygen to 35% of the air was oxygen. And because there was so much oxygen in the air, you could get gigantic insects. And so during the Carboniferous period, there were dragonflies, which were 70. They had 70 centimeter wingspan. I mean, you can't even. I can't even show you how big that is because my computer's too close. I gotta like put it in front of me and back up. But 70 centimeters, it's almost like a yardstick. So you have gigantic dragonflies. You had millipedes that could be 2 meters long. And they weren't like skinny millipedes that were 2 meters long. They were like Mr. O, you know. If Mr. O was a millipede crawling around the ground, lots of legs going all over. Oh, it makes my skin crawl. Anyways, the point being was that the Carboniferous period was a time that life really proliferated on land. There was lots of life on land. There were all kinds of bugs moving everywhere. There were some what they call tetrapods, which are like, you know, some proto-reptiles, proto-mammals, some, you know, earlier forms of life moving around on land. And also the environment was very swampy in lots of places. And one important thing to note is that plants at that time first started developing into tree-like organisms. And these tree-like organisms had this bark which was incredibly thick and incredibly tough. It was much thicker than like tree bark usually is nowadays. And anyways, a consequence of I guess the structure of trees, full of like thick bark, and then also the swampy landscape. And then on top of that, there weren't a lot of decomposers like fungus or animals that could eat this thick, heavy bark on the trees. And so what that caused was when living things would fall during the Carboniferous period, they really didn't go away. They fell into these swamps, which didn't have a lot of oxygen. And so, yeah, they did not decompose. They did not break down into soil again. They just became dead living things that were submerged in the water. And then more and more dead living things would fall on them. Sediments would pile up, and then eventually you would end up with fossil fuels. So this dead organic matter accumulates, covered by sediment, transformed into fossil fuels by heat and pressure. And when we talk about coal, coal is actually a sedimentary rock. And so it's a sedimentary rock that is actually made from organic material. And so coal, as I explained before, sedimentary rock, formed from undecayed organic matter from Earth's heat and pressure. And then we have another type of fossil fuel, which is oil, which is basically a liquid form of coal. And then we have natural gas, which is a gaseous form of this organic material which gets squeezed and compressed, and eventually it will create pockets of natural gas. Lots of you use natural gas in your homes. If you see these blue flames on your stove, that's natural gas. So the way we get fossil fuels out of the earth is very destructive to the environment as well. So when it comes to coal mining is, and it was historically just a really dangerous job. You had to dig deep tunnels in the ground. Those tunnels could collapse. Sometimes the tunnels would run out of oxygen and people would asphyxiate. They would choke to death under the ground. And even if you didn't meet a sudden death underground, digging up the coal created a lot of coal dust, and breathing the coal dust would cause something called black lung, which would really kind of literally make your lungs rot away, and you couldn't breathe, you had trouble breathing, and you would die very young because you couldn't breathe well enough. So anyways, coal mining was extremely dangerous, was extremely harmful to the people doing it. And so eventually they decided, instead of drilling into the ground to extract coal, that they would just explode entire mountains and then pick through the rubble of mountains to gather up coal. And this is called mountaintop removal mining. It's something that was terrible for the environment because you had to destroy entire mountains and forests that were in and around the mountains. And then furthermore, it exposed all of these heavy metals and toxic materials to the open air. And even things like the coal dust would mix with rainwater. It would form sludge, and the sludge was poisonous to everything that was alive. So it was a really terrible way of mining. People were still getting sick. Not only were the miners getting sick, but also local people were getting sick because of the pollutants running into the rainwater, killing off fish or making the fish toxic. So anyways, terrible thing. In the 1990s, they began to make efforts to clean up these areas that had mountaintop removal mining, and they were trying to limit mountaintop removal mining. But thanks to President Trump, mountaintop removal mining is now making a comeback, and so this is happening again at a much more rapid pace than it did before, and it's having a very negative effect on our environment. So oil extraction, as you know, it happens in lots of different ways. In the background of our slides, we can see the BP Deepwater Horizon oil rig. That oil rig exploded in the Gulf of Mexico. It spilled millions of tons of oil into the Gulf of Mexico, poisoned all kinds of living things that are there in the Gulf of Mexico, including a lot of things that we use for food like shrimp, fish. A lot of it is still poisoned because of this explosion. And then, of course, the fire sent lots of greenhouse gases into the air as well. So oil extraction is another thing that is extremely dangerous for the environment. Last year there was the protest at Standing Rock, and people, they didn't want oil pipelines going over Native American land because those pipes inevitably break, they leak, and that oil gets in the groundwater, and then people, they don't have clean water to drink anymore. Finally, we have natural gas. Natural gas is extracted by a process called fracking these days, and they basically drill holes into the ground, and then they drill if this is the ground, they drill a hole down, and then they drill another, channel sideways, and then they force water into these channels, which breaks up the earth and releases the natural gas, and then they extract the natural gas. Fracking is also extremely bad for the environment. It's extremely bad for people who live around fracking. It's extremely noisy. People have described some of the effects of living near fracking as similar to people who live near bombing ranges where bombs are exploding all the time. So they just have intense hearing damage, they have problems sleeping, they have difficulty with balance, and they have other neurological problems as well. Anyways, fossil fuel extraction is not only very dangerous, it's bad for the environment, and it's bad for people who are either doing it or living close to it. However, even though that fossil fuels are terrible, Our world is run by fossil fuels. So 63% of US electrical plants use fossil fuels. Here we see a coal burning plant burning coal so it can generate electricity. Almost all transportation in the US uses fossil fuels. So cars and trucks, they use gasoline, spew greenhouse gases into the air. Trains use diesel fuel, which again creates greenhouse gases. Boats, the same. Airplanes use jet fuel, again, more greenhouse gases. Plastics, anything that you have made from plastic is made out of oil that gets refined and sort of spun into these polymers, which eventually become plastics. Asphalt for roads, for airports, for parking lots, whatever. Asphalt is primarily created from oil as well. So all of this use of fossil fuels really disrupts what's called the carbon cycle. As I mentioned way back before even we were in coronavirus quarantine, Earth is a closed system, right? We've got a limited amount of carbon that is in the Earth, and that carbon gets recycled, right? We've got a limited amount of water that is in the Earth, and that water gets recycled. So for carbon, it gets created and destroyed. It gets created, stored, and I shouldn't say destroyed. It gets created, stored, and sort of redistributed through lots of natural cycles. So yeah, it's cycled in and out from air to living things. It decomposes into soil and sediment. It transforms into limestone, and in some cases, when it sinks to the bottom of the ocean floor, that ocean floor, the plate of the ocean floors, they move, they subduct, and then that goes back into the earth. And once it goes back into the earth, eventually it finds its way out through volcanic activity. And so there's a balance in the amount of, in the way that carbon is sort of created, put into the air, taken from the air, used by plants, used by living things. Those living things die, they go back under the earth. From under the earth, carbon dioxide rises through. So anyways, it's a cycle. There's a balance to it. But since we are extracting all of this stored carbon from the earth and burning it so quickly, it is causing rapid changes to our environment. And so here is just a very quick breakdown of the carbon cycle. Carbon into the earth, carbon into the air, and these are natural cycles. Even things like fires, wildfires are natural, volcanoes are natural, decomposition is natural, but we are interrupting this carbon cycle, and that in turn is causing climate change. We'll talk more about climate change tomorrow, but for now we're going to just go ahead and put on the brakes. You don't have any separate assignments besides your entrance task, so don't worry about any other writings. If you do have any other questions, feel free to contact Mr. O or I. You can contact me at sjkwok@sejongacademy.org, Mr. O at hoh1@sejongacademy.org. Also, every morning from 9:30 to 10:30 a.m. I have office hours, so hit me up then. I'd be glad to see you. And then for all of you who sent me a message earlier this week, please be patient. What time is it now? I don't even know what time it is. It's close to midnight though, so I'm going to bed. So I'll get back to you later. Thank you for being patient, and I hope you have a great day. Peace.